Excellent. All right, welcome back to, I think this is week 3, I believe. All right, and just quickly using 5 minutes to recap the knowledge points, what we learned so far. Okay, trigonometry, we had to learn a bit of knowledge, a bit of application, more about definition of application, right? Definition of the terminology in terms of application. So that's basically the 2 major pieces that we have learned so far. All right, so first one, the definition, right? Or the knowledge point of trigonometry. So what we have learned is angle that less than 90 degree. Pretty much everything related to that. So because of angle less than 90 degree, you can always using this one to model, right? You can always using the right angle triangle to model. So everything is going to be in the context of hypotenuse, opposite or adjacent, right? The angle alpha here. So just remember, I have mentioned before, hypotenuse is regardless of angle. However, opposite or adjacent, they're meaningless unless you specify the angle first, right? If a student, it's quite a lot when I'm marking prior year student, is they doing this, just like a hypotenuse, OPP, ADJ. They do that. So I will have a question mark say, where is the angle? Does that make sense? Because OPP, ADJ, you need to put that in the context of the angle. What if the angle is here? If the angle is here, these 2 components need to be swapped, right? So OPP is here, ADJ is there. So that's why I said OPP and ADJ is relevant to the angle you talk about. So if you put an angle alpha and beta in the same horizon, same diagram, so you should skip this marking completely. You should not mention OPP and ADJ anymore because you have 2 angles. Regardless whether you put it on, it's wrong, right? You can't just put OPP there because it's OPP is only for alpha, but it's not for beta. So the conclusion is don't put anything, right? Just leave like that. And just remember that. So then I think that's the first thing I want to emphasize. Second things I want to emphasize on is there is a relation. I was thinking, try hard to think about a better way to visualize sine, cosine, tangent, cotangent, secant, cosecant. So I had it done all those sort of mapping, right? Now I'm thinking about this. Is this possible? Let's do that, right? Say we have, let me just make a big one, right? So we have sine, we have cosine, we have tangent, we have, so that things need to be look like that. Let me make it, right? So I was thinking about that. So okay, so the opposite side is the reciprocal relationship. So that one, oh no, yeah, bigger, no, do it again. Secant, that one is a cosecant, and that one is cotangent. Maybe I'm adding a little bit longer term. So yeah, cotangent. So this one I add cosine. All right. So when you try to draw that, what kind of relation that I try to show is that. So first layer of relation that we already know is this. In this kind of 6 whatever hexagon shape, right? The opposite circle representing a relation of reciprocal. Yeah, that's the first layer of relation. reciprocal, right? They are reciprocal to each other. So sine, the reciprocal is cosecant. Cosine, the reciprocal is secant. Tangent, the reciprocal is cotangent. That's the first layer. The second one is this, right? So you have a red color. So this one versus that, they are complementary angle. So what shall we say? It's a complementary identity, right? It's complementary. Yeah, supplementary and complementary. So what that means, because I think I briefly mentioned that if you talk about sine 30, we all know that's equal to cosine 60. But the reason is because cosine 60, 60 means 90 minus 30. So when you introduce a co, stands for complementary. The same time you introduce angle with a complementary angle, they just offset each other. So that's why anytime if you want to change in sine to cosine, very easy. If you want to change in secant to cosecant, very easy. If you want to change tangent to cotangent, very easy as well. You simply just swap the angle. The angle changed to complementary angle. So because each of them had a word co, can you see that? Co. Co stands for complementary. So now you can see the secant versus cosecant follow that relation, and additionally is this one. Tangent versus cotangent also follow that complementary relation. So you can see now you have how many pair relation? 3 pair plus another 3 pair, 6 pair of relations. That's a important connections that you put in your mind, back of your mind. In the future, when you need to convert from one to the other, right? There is a things that is available directly. But by saying that, if you're really confused, you can always go back to this is the plan. This is plan A. What I mean plan A? So for example, I'm just made it up here, right? If I have sine alpha equal to 1/7, if you want to calculate what is the cotangent, you won't have any directions to calculate cotangent anyway. So plan A is used. So what you do, you just quickly do this. That's a 7, that's a 1, that's a 48 root, right? 49 root, right? So 48 root is 4 root 3. Okay, so then if you say how to calculate the cotangent, easy peasy, right? So adjacent divided by opposite. So it's 4 root 3, down. So this is the angle side. So 4 root 3 is that. Okay, so this is what I said. All you need to learn in the topic 1 is that you got the idea of how to convert by using right angle triangle. So that's what I said. The conversion is plan A. The plan B is that in the only special cases, this is plan A. I just drag that to that area so you can see that's the plan A. So the plan, make this one slightly closer so you can see what I'm talking about. So the plan B is just using these relations. So for example, if I'm getting cotangent 37, how can I get a tangent? So one way to get tangent is tangent 53 degree down. But you can also using 1/tangent 37. So you have two options. Why? Because you have not only the what's called the bluish, dark bluish relation, but also have a red relation, which is complementary angle relation. So you can have either one, whichever one is easier for you to do the conversion. Okay. All right. So I think we're probably not gonna go too deep, but I'm just try to just give you the idea why we have this kind of a summary is there's things connected. Okay, done. The second point that we want to quickly cover is those application. So in terms of application, there is a terminology that you need to get a head around. So in order to give you a very clear instruction, clear sort of definition, you probably just first, you draw a benchmark, which is, I think it's called due, what we call that? Due east, something like that. Not necessarily east, right? So horizontal. This is the horizontal one. Horizontal one is the benchmark. So if you go up, right, this is called alpha that go down, called beta. So the alpha is called angle of elevation, while the beta is called angle of depression. Right, so this is two terminology that you're using. Cool. In terms of that, once you understand that there is a second pair of relation is called true bearing and a compass bearing. So I just put it in the context of a system of like compass, right? A system of compass. Using an example maybe is more appropriate like that. Just one example shows the story. Okay, that one I call that 15 degree. All right. Now for this one, what's the name? Like how can we define? How can we define this direction? Right. So if it's if you're using compass, bearing is going to be north. Yeah, because that's north. And it's towards the west. What's the number in between? You're not looking at a 15 degree, right? You're looking at north being biased towards west by how much degree? It's a 75, right? So the result is north 75 degree west. Okay, so that's compass bearing. So compass bearing is a swing from, so let's just quickly comment on what the compass bearing is. The angle, the starting point of the angle is north or south. Yep, because they always start with this word N or S. You will never start with W or E. So that's one thing is very important. The secondly, the angle, right? Angle is measuring, like the angle, whatever the angle in the compass bearing, right? The C dot B, the compass bearing will always less than 90 degree, less than or equal to 90 degree. Because you won't have any angles like more than 90 degree, because think about it, right? Anywhere, if here, right? What's that? It's got a south and swing by 30 degree, right? So that's a south, but there is nothing is possible to above for the compass bearing above 90. It's not possible, right? So that's something you need to put in, yeah, think about it. So that's done. Now the same thing, for the same thing, we call that N75W, right? But the same thing, what is the true bearing? The true bearing is start from where? Maybe I ask this question to students. So Coco Do, are you able to answer? True bearing is
It's starting from north
Yes. So what's the
and
angle
going
for that things? What's the angle?
225.
Think about it again.
Oh, wait. 285.
Correct. So what we should write? True bearing is right like that. 285° T. Okay, so that's a true bearing. So also we want to quickly comment on the two same thing, right? We just comment on what is the starting point, what's the range, right? So I think its range is less than 90. So let's do that, right? The starting point of the angle is pure north, just the north, right? Because the starting point of the compass bearing is either north or south, right? The starting point is that. The second point is the angle measured in which way? In clockwise, right? So it's like the angle is measured clockwise. But in the previous case, compass bearing, the angle is not measuring clockwise or counterclockwise, not measuring that way. It just depends on the angle. It depends swing towards either like the range is that, and the angle is swing to west, which is this way, or east, which is that way. Because like the angle is measuring based on the swing, right? Whether it's swing to the left or swing to the right, there's only one of them. So and the true bearing is difficult in the sense that they are not doing that kind of swing. They're doing true bearing is the calculation like that. So I'm probably using a color like that. They're measuring this angle. So you can see the starting point is pure north and the clockwise measuring. So each of the right angles 90 degrees, that's 270° plus 15, that's 285 exactly, right? So 285 T, that's the name for true bearing. So again, finalized, you gotta say what the true bearing, what's the possible range? For true bearing, what's the possible range? True bearing is obviously greater than 0. I'm not mentioning that, but it's less than, not equal to 360. So usually you don't see true bearing 360 because technically 360T equal to 000T, right? Because that's a one revolution. So usually don't have 360D. The highest number is 359T, which means somewhere like that. So it's very, very close to the pure north, but slightly swing to the left, to the west. Okay, so I think that's just close out the concept of four things. Just recap, right? For very simple angle application, trigonometry application, you will talk about angle of elevation, angle of depression, and there's two bearing. Compass bearing make more sense to everyone, and true bearing is a difficult one. But that's where all the exam is focused on true bearing, because that's where you're confused about, right? That's where you're confused about, so that's where you need to prepare for. I'm looking at the name, right? Someone, what is someone? Please just change all the names to your register name, because I saw one student name. I'm not sure. Maybe it is. Oh, it is Eric, right? Sorry, because I thought like, what's her name? You probably just make a space between your surname. If I will understand who you are. It's fine. All right. Okay. So with that things in, we are going to quickly cover some of the questions. So last week, let me check what's homework. I think I'm asking you to the halfway through, right? Halfway. Yep. I think last week we have asked you to do the homework. Let me check. Oscar, did you do homework? Maybe not. Yes? Did you submit homework?
Yeah, I submitted it. You're going to pass.
Yeah, guys, just need to the submit is just for me to understand where you are, right? If no one submit, then even you do the homework, I don't know, right? So we have like a half of students submitted, the other half is not. The last week's question I'll ask you to do 6A, question 21. It's the question we discussed, and 6B, question 5 to 14 and 18. All right, let's quickly cover that. Then we can see other questions. So from 5 to 14, this is one we discussed. So how about the easy one? I'm asking you guys to. So I have question 5, 6, 7, 8. Can I ask you guys to do? So let me think about a space. Let's move up a little bit. Yep. So 5, 6, 7, 8. It's part of homework, but I'm just trying to see any issues, any problems, and let's volunteer. Any volunteers? Jeff, good. So 5, question 5. Jeff, question 6. There's lots of hand up already. Ivan He. Question 7. Okay, Ren Jie. Oh, wait, Jason, sorry. Ren Jie, you got one. Don't worry. Cool. Jason L. So that's Jason Lee or something. Okay. Yep. Try to do that on the share screen. For students that you already done, you can try to do the question that I haven't asked you to do. For example, 15, 16, 17, that's 3 questions is something you can try. After that, after 18, there's 19, 20, 21, 22. Yeah, there is all those questions is something that you should try. Because those questions, some of them is slightly challenging, right? Okay. So for this question, right, a few things I just want to comment on. For example, everybody will have a rounding requirement. So I'll just check it out, right? So this is correct to 1 dp, right? Correct to 1 decimal place, correct to nearest kilometers, correct to nearest meters. Okay, now, so just put in the example of Jeff's question, question 5. Because it's 1 decimal requirement, we just need to get a theory correct. Do you think what kind of, like, what's your level of requirement of accuracy? right? At the middle step. So it's a kind of common sense. If you never think about it, you will have problems. So because this is 1 dp, I just put a conclusion first, right? In order to achieve 1 decimal place accuracy, you need to have at least 2 dp in the middle step. Okay? For those addition questions. For question is time, you need to have 3 dp or 4 dp to ensure the final steps correct. If that number is an index, you need to have 5 dp, 6 dp to accurately, because it's depending on the number sensitivities towards your final result. So for a question like that, right, just to give you an example, because AB and BC need to add up. What if you get AB, right, is equal to, you're running down, right? So 2.14, so you run down. And the BC is 3.14. I'm just made it up, right? So if you have that, your result adds up as 5.28, you run up to 5.3. You agree? Yeah. But if you just at the middle step, you run off, say 4, running down. So what's your final result? Your final result is 5.2. So it's pretty obvious 5.2 is wrong. Is that obvious? Because if you keep long decimals, your result is 5.3, but you got 5.2. Do you get a full mark? Of course not. So are we learning the lesson here? So I think the lesson 1 today about those kind of application benefit are like those application question, right? A little bit techniques or skills is that you need to understand as a middle step, rounding requirement is higher than the final step, right? So yeah, in order to achieve 1 decimal accuracy, you need to probably keep 3 decimals for safety, just like that, right? If that makes sense, maybe, yeah, I think Jeff has already fixed it. So Jeff's question maybe is not a big issue. You can see one of them is run up, one of them is run down. That's most likely it is the case. So it's regardless, it's not going to impact on his result, regardless, right? But sometimes it does. Okay. So let's looking at, so the Jeff write it down is very good steps, I believe. So I have nothing to add. Nothing to add. Okay, so 阿文和 you do sine 36 is 1.5 divided by, you call this A, right? Good. And so A is 1.5. No, I think you're wrong here. You're doing your calculation. Solve the A. A is move to the left, 1.5 stay. The sign move to the right in the bottom. So it's gonna be, this one is flipped. Ivan, is that right? Do you believe?
Yeah,
I think
remember
your
the
calculation is right. I think your
Yes,
calculation might be right. Yeah. Because otherwise it won't make sense, right? You have a less than 1 number divided by 1.5, even smaller. Okay, so the numbers look like right. Question 7. So Jason is drive 100 kilometers, 120 kilometers on the bearing of 130. Yeah, that's 130. That means here is 50, right? It's a supplementary angle. All right, 130, 50, that's a 50. So good. And she then drive due west. Guys, learn something, right? Due west. So there's multiple places that you will see due. What do you mean? Due means pure, exact. Right? So I think in this case, this is my interpretation. Due is exactly means there's nothing. Just drive west, exactly on the west. Right? So the question is going to go this way. 100 go this way and due west. So the direction is this way and that way. and due south. So it's this time is not direction, it's drive due west is the direction. But then she said until she is due south. Again, is just like still interpret as the word pew. She is pew south. So she's here at her starting point. How far is she from her starting point? Correct. So you want to calculate that x. Okay. So you call that D. Okay, that's fine. So the question is going to be cosine 50 is that. Very good. So D is 120 times cosine 50 is 77. So I don't check this number, but I believe this is correct. Yeah, I believe this is correct. All right, Renjie, the last one. Jason's looking out a window at a car. So the cars are here, windows there, and park on the street below. If the angle of depression of the car from the window. So now another word that you need to pay attention to is from, right? So the angle of depression of C. Just remember how it's been phrased. Angle of depression of C from A. So can you see if you talk about a direction that's going read downwards, right? Can you see how the position of C and W? Would it be someone just read like an angle of depression of W to C or of C from W? So the keyword from that decide the direction how you read it, like how the eye is watching, right? The eye is watching from W towards C. That's why it says angle of depression of C from W. Okay, so I think I just want you to watch out to the word of from. From is very important word in this kind of semi-geometry questions, because you always get confused about what the language is, right? But you just forget about all other things. The word from is absolutely clear. The instruction is clear, right? The word from, it decided the angle, like this arrow is toward this way, because the from W obviously toward that way. So this kind of a reading the W, the from word is also pretty important for us to decide true bearings, right? Because it's very easy to confuse which direction you are supposed to measure. All right, cool. So that's down. And so the car is 7 meters from that. To find the height of W, the building, all right, the WB of the window, correct to the nearest meters. So again, it's you can see this is 73. That's called alternate angle. So this is also 73. All right, so it's alternate angle. Tan 73 is WB over 7. Yep. So WB is tan 73 times 7 eventually is 23. I believe that's, oh wait, let me check. Tangent. Oh yeah, that's about right. Yeah, 23. Cool. So those questions, I think, I just want to touch base on a couple of language word. One of due, what's due west, due south mean? And the other word is when you read through questions, whenever you're confused about, say, BC, right? Anywhere, right? So this is B, this is C. If you just ask you, calculate the true bearing of BC or CB, you're very confused, right? You could have two different directions. So the true bearing towards from B to C, it's going to be the angle measurement like that. Yep. It's the true bearing BC is going to measure like that. However, the true bearing of CB is going to measure like that. If you're measuring the CB true bearing, is looking like that. So it's very, very different in terms of what direction you're looking at. So in this kind of case, when you're not sure whether it's BC or CB, what are you looking at? You're looking at a word from. It absolutely will have the word from somewhere. You just need to dig it out. Looking at a word from, you absolutely clear who to who. Like which one is the starting point, which is ending point. With the arrow being printed, right? With the arrows being drawn, the bearing is very clear, right? This is called the bearing. If you go that way, the bearing is not like a draw like that. It's draw this way. That's the bearing. Hope that makes sense. Okay. All right. Done. So that part, everybody's successful. Very good. Let me just clean them up. Cool. Let's just move on. This one doesn't need to be cleaned. We can deal with that later. All right. So development. Those questions shouldn't be a big issue, but that question 45, yeah. So question 12 and 13, it was a go. Maybe 10, 11 as well. So let's do that. We have 4 questions. Let me planning a little bit. How should I plan this 4 question? So here, each person have a big space like that. And on the top, it's going to be question 10. Cool. So let's do it. Anyone want to give a try? Okay. Eva, you already had a chance. Jeff, you already had a chance. So let's just get different people. Coco. You call your full Chinese name, Shou Fu. Yeah, Coco. I know you're Coco. So Coco. Ivan C. I'll give you the harder one. Supposed to be harder. I don't know. Question 12. Marco Ma. I'll give you the other one with the diagram. Marco Ma, question 13. Kevin. So Kevin, what's your surname? Please put on, because I remember there's other Kevin before. So just add your surname so we know who you are. All right, so new student, like Eric. There's 2 Eric. Please put a surname, like Eric Law, I already see that. But the other Eric, put a surname down so I can call you properly. All right, so if you haven't done, do the question. If you've done it already, as I said, do the other questions. There's lots of them. Wow, Marco, you short sleeve. Are you cold?
Oh, I just took off my jacket. It was just a bit warm here.
Oh, that's good. Does it look like you're in the summer? I mean, the winter.
Oh,
Just be relaxed a little bit, Marco. You must be excited to do the question. Cool, guys. Everyone else, if you like, you should turn on your video cameras, guys. I'll remind you again, it's more focused. So I can see you guys as well. Liz, your light is very bright. I can't see you, but anyway, I can sense you. I can feel like it's you. All right, so the first question, find the correct to the nearest 10th of meter. So Coco, you know what that means? 0.1 meter, right? The height of the tower, if the angle of elevation top of the tower is 64 from a point on the horizontal ground, 10 meters from the base of tower. Yep, that's fine. So tangent. Yeah, that's fine. So I believe, okay, so one thing I would ask Coco, right? Because you already did it. Students, guys, did everybody have your calculator ready? Everybody? Yeah? Because I just asked Coco, but everybody just listen, right? Coco, how do you enter 64, 48? 64 degree, 48 minutes.
By pressing this DMS button.
Yeah, you press, like you're doing the press the tangent first, right? Let's just do that. Maybe you just draw the button, say, because you have a button on the screen, right? Like you just draw, say, for example, this is stands for button tangent. So you can say, how do you calculate the X? What do you have entered? So obviously you have entered the 10 time, yeah, button tangent. Yep. What do you, the DMS? Do you have this button? Good. But like not everybody have this button. So you can write it down DMS if you have this. So what I have is, oh, you have DMS, right? So in what version your calculator is? What show us. Just lift up. Panasonic. Oh, okay. Okay, I saw that. So DMS is one of those, but a majority of the Casio version, they have this button called this one. Okay, so 1064 DMS, then you'd enter 48. Yep. Then enter. Do you need to press this button again? I need, because in the Casio FX 100 AU plus, you need to do that again. Because if you know that, allow me to just be repeating, because I do saw students still confused. Because I have a student that asked me in the Saturday class, say, why it doesn't work if I'm enter 1064, that button, right? Why is it just throw error? I tried. I think it is throw error. No, it's not throw error. So I'm not sure. Maybe not. Because whether you need to press this button for any whole number of angle, it doesn't necessarily important. Like you can just do tangent, right? Tangent 64 works. Whether you press the DMS button is not that important. But if you want to have minutes entered, you do need to do that, right? Tangent 64, press 48. Oh yeah, so important to press again, because if you don't enter this in our calculator, if you don't enter this, you will throw error. If you just close wrong, yeah, it's system error. So you have to remember when you do tangent 64, I need to enter this button twice, right? Because each number, when you finish, enter, because you might end up with another what's called minutes, second as well. You don't need to enter second if isn't, but you still need to close it out, this button. All right, I'm just mentioning that in case you have a problem. I do have another student, by the way. They said, I don't have the one DMS or things at all. So what should I do? So I tell them, right? If you really have nothing, you can do this. Tangent, right? Then you enter 64, or before 64, you do bracket plus 48 divided by 60. That still works. You can try. So that's a purely the adjustment way, because 48 is a minute. You convert that to degree first. So like that's what you do. Tangent 64 plus 48 divided by 60, close bracket. You still can generate exact result. Are they same? Why I'm getting different result? Wait, sine 630. Yep. Tangent 64 plus 48 divided by 60, close bracket, 2.125, and time 10, 21.3. Yeah, that's correct. So do that, tangent 64, 48. Yeah, it's correct. It's fine. Time 10. Okay. So just take the time to discuss how to using calculator a little bit, but otherwise, very good. All right, Kevin. Question 11. So a boat is 200 meters out to the ocean. All right, good. From the vertical cliff, height is 40. Very good. Find correct to the nearest degree the angle of depression of the boat from the top of the cliff. So this is the top of cliff. This is the boat. I think you probably using ABC need to be more precisely. So what usually, right, Kevin? Because you probably confuse other people about the name. So it is the cliff, that's the sea. It's the boat, that's the bay. That way probably is better. So let's see. So the question, a boat is 200 meters out in the sea, vertical cliff, the height of 40. Find the correct nearest degree, a angle of depression of the boat from top of a cliff. Yep. So this is top. Yeah, I don't know what you call it that. You probably just call it A. That's fine. So like A, B, C, look at that is better. Okay. So just want to see what's the angle. So Kevin, can you mark in the angle of angle R? So you said the angle of depression is 90 minus theta. Yeah, that's fine. So you should mark in this. Angle of depression is this one. That's the alpha. And due to the alternate angle, but parallelogram, it's not parallel, no. Parallel line angle relation. This is alternate angle. So this is the angle of depression, same as this angle. So once you have this alpha, you should be able to straight away connect the 200 meter and 40 together. So you can tangent. So I'll do differently. 40 divided by 200. So it's a 1/5. Okay. So what's the question? A boat is 200 meters out of sea. Yep. Find the correct nearest degree. So yep, the alpha is tangent negative 1/5. So it's a nearest degree, right? Correct nearest degree. So let's do arcsine or arctangent 1/5. Close bracket. $11.3. So it is 11, correct. Okay, so the guys, how to draw, if you want to visualize where is the angle of depression, this should be the angle, guys. So don't confuse other people to draw here. Not really necessary. although you make it very clear, specify angle of depression, that makes sense. So that's good. All right, so I will see your question. Pot Q is here. Yep. Is 45. There is it's like ocean mile, right? It's a nautical miles from pot B on the bearing of 0.55. So this is 0.55 degree. Pot R is 65 away. So this is 65 mile from the pot P. Okay. And PQR is 90 degrees. So the diagram is not very, you're not completing the diagram. I don't know why this is 46, but let's see why that's 46. Don't have idea, but let's see. How are we going next? Find angle QPR. Okay. Has found the bearing of R from P. Yeah, so the bearing is supposed to calculate this line. That's good, correct to nearest degree. All right, so let's looking at the questions. What information we have? We have Q is 45 from P. So this is angle, so this line is 45. 65. Yep. Because this is 90 degrees, so you can use that. So cosine is, so you probably need to mark in the theta here. Marking this is theta, that's better. The marking theta, cosine theta is 45 divided by 65. So theta is arc cosine. Yep, you got 46. Good. So this adds up 100, 101T. That's correct. So let's see what's the true bearing. True bearing is, let's just clean this all up. The true bearing is this line, right? So this is the angle of true bearing. From there to there is the true bearing because this is the pure north. Okay, done. All right, Makoma, let's look at your one. Look at your one. The question 13. The bearing of, let me check the diagram. Here's the diagram. Okay, so you make this A. Okay, all right. The bearing of tower Y here from Z. Let's just read the question properly. The bearing of tower Y from Z. Yeah, okay, so this is the bearing, right? Is 60 degree. Bearing of the tower Y from tower Y and Z, or from X. All right, okay, I just confused. So that one is 60. Yeah. Tower Y and Z from X. So X to Y is one direction, is 60. The other one, Z from X, this one, that's going to be a bigger revolution, 330. So that's a 30. All right, so you got that. 30 and a 60. Brilliant. Show that's 90. Yeah, of course it's 90 because it add up. So 60, 30. So angle AXY. Yeah, very good. AXZ, very good. So it's 90, very good. All right, given that tower Z is 80 kilometers from X. Okay, so this is 80. And the angle is X X, Y, Z is 50. So this is the 50 now. If that one is 50, okay. Find the correct or nearest kilometers, how far the town Y is from X. So the diagram is this one is 50. I think I'm drawing here. This is 50. And where's the information? 80 is Z from X, Z. You just need to marking all those numbers up. Z to X is 80. Yeah, that should be enough. Okay. So this part, yeah, tangent 50 is equal to 80 divided by XY. Yeah, that's perfect. So that's XY is 80 divided by tangent 50 is going to be, let's do the punch in the calculator. Divided by tangent 50, 67. Yeah, that's good. Good. So guys, I think the practice shows pretty solid ground. I'm very happy, guys. You guys have a no problem at all in this case. Cool. Now we get into let's see, 14. Let's look at time. Time is 8 o'clock. Let's have a break. So let's have a short break. Come back at 5 minutes. Maybe yeah, 5. So it's 3 past 8. 8:03. Come back 8:03. We will continue. Okay. Come back 8:03. If any students around, if you want to do the questions, you can raise your hand. I'll get you to do now. If you're around, right? If you are taking break, it's fine. Don't worry. Yep. If you're around, you want to give a go, you can. Let me see. So we get only one. Okay, Jeff, you want to do? Good. All right, Jeff, do question 14. Ivan C, 16A. 16B, Ivan He. And anyone else? All right, it's fine. If no one, it's fine. We'll let people waiting when it back. So anyone interested to do question 16C? You can just raise hand. I'll let you go. Let you do it. I'm checking, right? Leeds, are you around? Do you want to do this? I probably give Leeds to do. If you come back late, just do quickly. You can have time to do it. Cool. If Leeds, if you're already back, you're supposed to do this question. Terrific. So the way that we are going to do 14 is part of homework, but 16 is not. Right? So 16, guys, if you haven't done homework, please do so. 15, I had a look at it. Looks like easy, but you still will welcome to do it. Polish yourself. But if you have limited time, do 16. The purpose to do 16 is try to understand a little bit of combination of algebra and geometry, because you won't be able to directly calculate what is x. You will not, right? But the way to do that is set up equation. You can definitely set up equation. So then by set up equation, you can indirectly working out the answer. Ivan C. I feel, oh, okay. Maybe you're right. I'm just looking at different question. All right, x plus 10. Ah, that makes sense. So the x, yeah, you're not allowed using decimals, Ivan. You need to calculate exact value. How would you do that? Tangent 60. All right, so I think that the reason why question 16 is something I want to do, what you guys do is that you need to know what is the exact value calculation. Because if you overly rely on your calculator, right? And so you need to, like as a basic requirement, for the angle of 30, 45, 60, you need to memorize the results. I mean, memorize means you don't looking at the reference table to know the result. So I usually don't want you to memorize. I want you to draw, quickly draw the diagram to figure out 1, 2, root 3. That's a 60. So if you have the question like 60 here, it's a tangent 60, so which is root 3. So I guess Ivan C, you might miss out this tangent 60 equal to root 3. This information is a bit of weak at your brain, right? You probably have to rely on the calculator to do that. So if that's the case, 10 root 3 is here. Right, so that's why x is 10 root 3 minus 10, which is exactly this result. Yep. So I guess what you do is you got that, and you also punch in the calculator. You got that. Say, oh, they are very close. Are you exactly correct? Not quite. You need to prove directly to get the result rather than calculate two different things. They end up with the same decimals. But technically, you not prove they're same because you just say the first decimal, they're both a decimal result. Their first three decimal are same, but it doesn't necessarily mean they are same, right? So hope that logically makes sense. You need to get directly. All right, let's marking the question Jeff doing first. So the question Jeff is doing, there is a multiple bearing here. So how to prove this is 90 degree? Let's see. 1Q RQ P. What is this? RQR? PQR? So what's this word? There's two of the R. I'm not getting confused. PQR. I think you're doing PQR. Angle PQR is 180 minus RPQ. I don't think so, Jeff. It's 90. PQR, RPQ, PQR. No, 90 is not right either. So why is 180? R, P, Q. Yeah, you're missing something, right? So R, PQ, and PQ, PRQ, PRQ. Yep, that's fine. So RPQ tangent RPQ is 120. Let's read it. R, P, Q, tangent. It's marking the numbers on it. So I'm marking the numbers, and they are 120 This is 120. Right. Now I'm clear what we're doing here. So you do tangent, this angle, but you can't, like up to here is okay. That's this step, you can't say that. Jeff, you cannot write like that. It's invalid. But like the previous step is okay. So this step is okay. You just need to calculate. No, I don't think 90 you can calculate like that. No. Because no one tell you it's 90 yet. How can you calculate a tangent? No, I think this calculation you assume it's 90, therefore like you can use this, right? So I don't think that's the logic is correct. You have to think about something else. I tell you, this is the first step. Yeah, the question is this. Right, the question really is ask you a plot from P to R. So this is the question B is ask you this, right? The true bearing from here to here, that's one question is B. For the A, it just ask you this, why this is Y. The question is why this is 90. So the calculation you're doing here is incorrect. So you think about something else, unless you wanted me to show you. Yeah, okay. So it's fine, Jeff. So I guess both parts, you probably need help, not only one. That's why this question is tricky. Let me explain, guys, but maybe I can ask you guys, think about it again. Where is the information you have not used? This is a more like a angle question in the geometry. So maybe I just give a audience a chance to try. Is there anyone want to try 14 that you understand how to do? You can explain to me. Because I'll give you a hint. Oven C, you work it out? Yeah. All right. So Oven C, you just need to working out to the 90 degree. I think
Sure.
that one is good one. You show us.
So basically,
Draw. That.
sure. So this angle over here and this one are co-interior.
Excellent.
So that means that
that's the
this
breakthrough.
one
Yeah.
is
That's a
70 and
Yep.
the entire thing is 360. So the outside two are 270. So the inside is 90.
Excellent. So that's just two equations to sort it out. Basically, yeah. Co-interior, get that 70, and a 70 plus 200, 270, 360 minus 270 is 90. Perfect. All right, so once you got that, how to calculate the next question? It's more like, it's not a trigonometry question. It's more like a language question. So anyone can like explain to me, do you understand what really the question asks you? Right, so maybe maybe Ivan C, you can continue. Do you understand what they're asking? You can marking the angle or marking what is the bearing of pot R from pot P mean?
So the bearing of port R, that's like N north, and we want to find out that.
Yeah. So, but before that, right, guys?
We need to find RPQ.
Yeah, but like, what's the key sort of? You are correct, by the way. I'm just trying to help everybody, right? Because it's a language problem people might confuse about. So where is the problem is, do you know, this is the things you need to read. The word from. Because the word from, P, and to the R. So it's very clearly tell you this arrow is towards this way. Once you have this one and you have other one, it's very obvious there's no other interpretation is possible to calculate the bearing. The bearing is only one. That's one. Okay. But in order to calculate that, you have a 110 is the base. So effectively, you just need to calculate this one. But because this 90 degrees is given, and all those number is provided, so this is 150, that one is 120. So now you can look at, okay, that's a tangent. This alpha equal to 120 over 150. So it's divided by 30, 4 over 5, right? Yeah. So 4 over 5, you calculate the alpha is arctangent 0.8 is what? Like just punch in the figures, arctangent 0.8, 38 degrees. So it is the bearing need to be rounded to the degree. So 39 degrees. Yep. And so the true bearing is 110 plus 39 degree. Because that's a 110, right? That's a 39. So it adds up 149 degree. So true bearing is 149 t. Just do a sense check. Is that right? Let me check, right? So it's a 40 degree plus that. Yeah, sounds like right. So that's the way how we're doing it. Okay, so 16A, I'm already marked. So the idea to do this question is not do the guess and check. The fundamental knowledge that you're missing, Ivan, right? Like is those 30, 60, 45, you need to memorize or memorize the process. How would you calculate those angles? So it's not very hard. Just to remember, draw the triangles. You just need to remember, draw the triangles. Is that hard to draw? No, right? You just draw this uneven triangle versus another, a very isosceles. There's two of them, right? The isosceles one is very simple. That's 1 root 2. The other uneven one, you just know this is 30, this is 60. So that's a 1, 2 root 3. Why is that 1, 2? 1, 2 is because that's corresponding to 30 degree. So once you get these two, any angle, any trigonometry from 30 and the 60, you can straight away jump into the conclusion, right? 30 degree, tangent, root 3. So we just need that root 3 here. Once you got that, we jump down. All right, the second question, let's see, Ivan He. X plus A is 10. Yep, that's true. You just made up the A. Yep. So tangent 30 is A divided by 10. Yep, so A is 10 times tangent 30. So what's that? Tangent 30. 30 is, yeah, tangent 30 is 1 over 3. Yeah. I got it. A is 10 divided by that. Yeah, that's fine. So that's A. Do we need to calculate A? No, we calculate X. 10 minus that. So it's a common denominator calculation. That will be, so this one first. So you realize eventually you need to do common denominator calculation. 3 over 10 root 3. Do that first. So then 10 minus that will be 10, 30 minus that. So take 10 out. It's 3, 10. Yeah, that's basically is this one. Good. So Ivan, you're just missing this part. If you do that earlier, it's much easier. But otherwise, it's still okay. All right, last question, Liz. You're supposed to calculate X. So So you got a 30, you got a 30, you got a 10. What's the best way to do it? So I think the best way is as one of the ways what Lee's doing, right? So you're missing one number, you just give a y. Otherwise, you have no idea how to explain properly. So the y is tangent 30, correct. And x is what? X is 10 times tangent. Yeah, so you're probably right, but Leeds, I feel like I suggest you looking at the way I write it down. Would you think considering next time, this is my way, right? So my way is tangent 60, right? This is tangent 60 is x plus y divided by 10, okay? Tangent 30 is y divided by 10. So what is x? Is that easy? X is 10 times tangent 60 minus tangent 30. Can you see that? Yeah, because y is 10 times tangent 30. So you substitute in, you got that result. So finally, the result is pretty straightforward. Root 3 minus 1 over root 3. So that's 3 over root 3. So it's a 2 over root 3 to 3. That's 20. So 20 root 3 divided by 3, and which is this number. So these to review what I have right. So the structure is following. For us in the future, right? We need to slightly switch the priority of your work. So I just review your work, right? You first step exactly same as me. Yep. But I usually don't do this step. I leave it later because you never know whether the effort you put in is worthwhile or not. Maybe not. Maybe yes. We unclear. And also you don't necessarily switch to the surds because the leave tangent seems like clear. You just punch in the surds later on. The second step is same, right? Because I think we are same, but you're already using the value for the second one. Feel like you don't like using the simultaneous equation, but I do. So just set up simultaneous equation. This is a skill for us to get in some partial marks. Even you stuff up later stage, right? This alone give you the marks. That one itself is a clear structure to show your understanding and to show examiner you do understand. So the remaining part is another partial mark. That's named called solving the simultaneous equation. So if it's a total 2 mark, the above is 1 mark, the bottom is another mark. All right, so come back to this situation. You get correct, no problem at all, right? But sometimes students just get mistakes at the beginning, like that. For example, you get mistake here, then you're losing mark for everything later on. You might only get a 0.5 here because you set up this equation. Anything else will make no sense, right? Because you get this wrong, then nothing will be correct for this one anymore. I'm just just to give example of what's the correct way of writing, what's the smart way, all right? Because either way is it correct. It's just the how do you do to maximize your chance of getting the partial mark, and also minimize the time that you might spend to solve the questions. All right, so that's good, guys. Let's move on to see whether we can try something hard. Not hard, right? So 18, I'll probably just give a, because for time management, let's just do quickly. 18 is the same thing, right? You have two angles being given, 64 and 39. Try to prove X. Try to calculate X. but there is no y. There's no y. So the question is going to, again, simultaneous equation. So how to do that? You would say tangent 39 is y over x, right? Sorry, not 7 over x, y over x, tangent 39. And then tangent 64, that is y plus 7 over x. So you have two equations set up. The problem is they are not asking you to solve the y. The question is try to solve the x. So that means in terms of simultaneous solving strategy, you very clearly know what you're supposed to do. You are eliminate. You're going to eliminate y. That's your goal, right? So how? How to eliminate y? It's a lots of different way, right? Student might say y equal to x times tangent 39. Yeah, you can do that. But you can also do is this whole block, you can replace this block. Let's try this, right? So that one is become tangent 39 plus 7 over x. You got that? So if that's the case, you will see x is what? X is 7 divided by tangent 64 minus tangent 39, which exactly is something you need, right? So why this question is interesting? Because this is simultaneous. It's kind of like a testing your geometry plus algebra combined skills. And the student usually remember or like to do step-by-step process. I just want you to switch. I just want you to, the mindset is start to switch, is the way, try to do a more like a set up teamwork. So when I say teamwork, a student will say, wow, we're individual work, where's teamwork? No, I'm talking about the teamwork is between your brain. Your brain have a different functionality, right? So you teamwork with brain, your part of brain, left brain or right, doesn't matter which part brain, right? The one part of brain is task is set up equation. That's part of brain. The other brain is solve the equation. Because these two parts is separately given the marks. Does that make sense? So do not try to zigzag. So what a zigzag means, you do some bit of setup equation and do some solving equation and do some setup equation and do some solving equation. That's not good. That's like a, that's not going to help you too much, to be honest. So what the best way to get in the lot more marks with the limited time is set up equation in one block. Usually is a simultaneous equation. Just like what I have done. That will already give you the half a mark straight away. Then next step, depending on how well you are in terms of solving abilities, you can solve, right? But even you can't solve, you will secure the marks for that first bit. That's quite important, right? Okay, so question 19 and 20. It's a harder question. I'll leave you to do. Okay, and I might give you a little bit hint, but there is a lot of different way to do it. So not that sort of not that hard, but you need to try. Like QR is the goal. You try to solve this in the unit of A. So it's not that horribly difficult, but you need to find out what is B. B is this angle. Now, what we need is a similar triangle concept. Let me zoom in a little bit this side so you can see. We need to understand, right? For this question, when you do it as a part of homework, question 19, right? You need to sort of looking at the question, what angle you have. You only have the angle B. So you need to have this angle. This is B. So many right angle triangles. So now tell me which other angle is B. You will say, I don't know. Yeah, It is tricky, right? So what is the other angle is B? You just need to think about that way, right? So so this is the B, but that angle is the complementary of B, so that will be the B. Yep, you happy with that? Because they both are, these two angles are complementary to this angle, so that's B. So find another one, right? So how about in this triangle, is any B? You don't know yet, right? Because this is the 90-degree, you can also argue to complementary to this angle. So this is complementary, but that one is also B. Yeah, but that one is pretty straightforward, called the alternate angle, right? So this three angle, they are B. What about the last one? Last one may not be relevant because this shape is obviously not following the angle B, but it doesn't need this anymore, right? So let's just focus on from A, how do you convert to QR? Okay. Oh, this is too wide. How to convert to QR? Right. So that way you are looking at like this angle, right? Yep. So there's multiple things you can connect. So first, how to connect A with one of the B? You might think, I can connect to this one. Am I right? Yeah. So BP is A, right? Time cosine B. That's for sure, right? This is A times cosine B, but become BP. Good. All right, so BP, you want to convert to which one? You can do BQ. Yeah, why not? So BQ is BP time cosine. So you have two of the cosine, right? So because this first one is BP, the whole thing, time another cosine, because that's cosine. So that's BQ. BQ is not done yet. So the final one is QR. QR is BQ time, how to get to the QR is a sine. So that's why you load it in, it's A sine B cosine B square, right? So that one is not hard. As you just step by step, the logic is following, right? You need to using your what's called the angle and the complementary angle logic to figure out who is the angle B. This is B, that's also B, that's also B. First step, you work out that. The second step is just from that perspective, gradually, step by step, working everything out. Okay, so that's done. You're going to do it, right? I'm just showing you the methodology already. All right, 19, done. 20. That's one of the tricky question. It's lots of students stuck there for 10 minutes, don't know how to do. But I'll give you, should I give you a hint? Let's just brainstorm how the question should be addressed. So looking at around the question, what other information you have? You need to, you have X, which is just assume is a given. The question doesn't really ask you to solve X and Y. They just want to find AQ. So where is AQ? AQ is here. Cool. All right. That's the AQ. So if you figure out AQ, and how would you be able to find out? So again, this is theta, right? If this is theta, what other things is theta? That one should be theta as well. Why? Because both are complementary to the angle ABP. Right? Both are complementary to the angle APB, so that's a theta. And now you're looking at a question, AQ is equal to X times cosine. X times cosine, yep, that part is pretty obvious. Yeah, that's X times cosine. So what about Y times sine? Is anything straight away available? Yes, it is. So I think I just share most important construction of this question is this line. You need to draw a line which is from C to BP as a what we say a perpendicular, right? Perpendicular angle. So let's see, ABCD, PQ, R is not used, just using the R, right? So ABCD, PQR, the R is here, CR. You construct a CR perpendicular to PB. So what you learn from there, once you have CR, you know PQCR. PQCR is a rectangle. Why? Because there's three angle is 90 degree, right? Three of them is 90 degree, so it's a rectangle. So once you have rectangle, your task of PQ is going to equal to CR. So what's the CR? CR is pretty straightforward. Y times sine theta. So that's why sounds like a very difficult question, can be easily convert because you adding this CR, you solve everything. All right, so I'll just give you the hint like that. I shouldn't give it to you because you should practice yourself, but because I know that you're probably gonna stuck there for 10-15 minutes, no idea what to do. So the key to success for this question is draw this line. Okay, that's it. All right, I guess we have other questions. Probably enrichment, I will give a skip, but the takeaway for enrichment is these two equations. What these two equations that it's a very important equation you're gonna learn in the future, right? When we learn in the future stage, this has become your compulsory knowledge. But not now. This is something we're gonna learn in the future called a compound angle and a double angle. So this is double angle formula. So this is double angle formula. We talk about sine 2 theta and cosine 2 theta. And there is a 2 formula that's a very, very important for, I think it is for extension 1 and extension 2, right? But now you're just learning it. So that's why this 2 question itself, not much particular meaningful things, but what meaningful is this 2 formula that if for some student very keen and very interesting to know new knowledge, this 2 is already presenting. So that's it. Okay. So the remaining 20 minutes, I would give a go for a start for next chapter. All right, so let's look at, there's only 2 pages of knowledge and not many, but the fundamental of this question, this booklet, this chapter is very important. Why that's more important? Because it's going to break through a new concept. The new concept is based on this diagram. We call it general angles, right? The language is called general angles. So bear with me. Now it's a new class, new topic, right? Let's just start from here. Okay, so what we have here is going to, everything so far we have discussed is angle less than 90 degree. So we call that version 1, where is theta is less than 90 degree. Now we want to break through to version 2, where the angle is greater than 0, but less than 360 degree. Or even higher, but let's start with 360 degree first. All right, and obviously you can also extend to a lot more, but this is version 2. I want you to extend, but then you probably will say more general, right? If this is the next step is general angles. Okay, so that's the sort of evolve, like how this is being getting more complicated, more extended than before. So remember the definition that we have to define a angle that where is less than 90 degree. You usually feel free to draw a right angle triangle like that. So you have put it in the context of OPP, hypotenuse, and ADJ. Remember that? So I'm probably just only simplify doing sine, cosine, tangent, right? So this one is OPP, HYP. This is ADJ, HYP. That one is OPP, ADJ. Yep, you probably think that's the end of story. No, it's just the beginning. All right, so now today we're going to define a trigonometry in a completely different framework. Why we say complete different framework? Because we are going to define that in this diagram called a unit circle. So this is like a, it's not necessarily a unit, but we can assume it's a unit in the later on where R is 1. That's called a unit circle. But in this diagram, R is not 1. So we can't call that unit circle, but the concept is the unit circle. All right. So once we have that, maybe I just need to make this big so guys can see it, right? Make it big. Okay, good. All right. So once we try to extend more than 90 degree, the triangle system, right? It won't work. It's going to be something you cannot plot, draw anything like more than 90 degree in the right angle triangle. That's impossible. But doesn't mean those trigonometry values, say, for example, right? Trigonometry value for sine 95 degree, you punch in the calculator, surprise, surprise, you still have value, right? That doesn't mean that you cannot calculate. So sine 95, you give a go, see what you got. You got 0.9961. So yeah, that's fine, can calculate it. What about cosine? Cosine 95, what you got? You can try to do that because you have some curiosity, say, what if you extend more than that? Let's do that. So cosine 95. And even more surprised, because the first time ever, you got negative numbers come up. Negative 0.08715556. That's a 0, sorry. So yeah, okay. So you notice that, oh, that's one change. So sine, cosine may possibly turn it into negatives. Yep. So yeah, that's where like things getting complicated, right? You could get positive, could get negative, but then they still can connect to their original value. So that's the thing, right? So what that means that if you are having sine, say sine 120 degree, so we can draw that on the diagram here, right? If you draw 120 degree, that's called 120 degree, right? If you try to say sine 120 degree, how to do that? Right, so leave that question to me. Let's just explain from very beginning. We need to define in a new framework. We need to define in a new framework what is sine, cosine, and tangent. So sine, we call that, so that was theta, we call this alpha, right? We call this tangent. Okay. And the starting point is always start with something simple. We're starting something simple that you draw a right angle triangle in this circle to start with. So in the right angle triangle, OP, maybe call this Q, right? So in the triangle, OPQ, what you observe, you will see the sine alpha is going to be PQ divided by OP. Are you happy with that? Because that's in the right angle triangle OPQ. The sine alpha is going to be PQ divided by OP. But then what is OP? OP have a name. It's called R, right? So that's R. What's PQ? PQ also have a name. It's called Y, because that's it being given, right? The coordinate of the P is called X and Y. So that's Y over R. Done. We got it, right? So that means we have able to rewrite the formula not in the opposite, hypotenuse, adjacent framework. We are now in the framework of X, Y, R. We're using X, Y, R to replace previous definition. So now sine is Y over X. So what about cosine? Cosine is, I'll just do it here, right? Cosine is OQ divided by R. What is OQ? OQ is X. So yep, that's X divided by R is cosine. What about tangent? Tangent, you just do a ratio, right? So it's Y over X. That's tangent. Now you have a completely new definition. So why is a completely new definition? You will say, are they same? For following the same logic? Yes, it's so far following the same logic, but you have a absolutely strong, meaningful things you can extend. So once you define it in X, Y, Z, guess what? Because X and Y can be negative, right? So the X and the Y can be negative, can be positive. So let's just do this sign things, right? X, Y can be positive, can be negative, can be positive, can be negative. R, it will only be positive. So with that things in, every single value are possible to be positive and negative. Yep. And also you can see once you define like that, let's do experiment, right? If we say this the theta, right, move to here. Do we still have the same value, same structure? Give a go, right? So you have the P is here. You still have the X is here. You still have Y there. And yeah, the X is negative. That's fine. So that means your cosine will be negative. Yep. So now you have idea say, oh, once we define the sine, cosine, tangent in a new framework X, Y, Z, we are able to extend the ability, extend an angle more than 90 degree, but still within a revolution. But last is a pretty easy one, is what about from 360 degree to something more? And that's pretty sure like this, right? If this is the angle called, let me see, right? 50 degree, I just made it up, look like a 50. But then what the theta can be? Some student might say, theta is just a theta, right? Theta is just a 50 degree. Are they right? No. Why not? Because it could also be 360 n. So the theta that they call ray, so this line is called a ray. Just like a light, you know, the ray. This is the ray. The ray represent a sequence of angles. They're not only one angle, they are representing a family of angles. They start with the basic angle within the first revolution, you give an angle called 50. Then you give a 360 time multiple, this is called a multiple revolution, like a, yeah, multiple turn. So any ray can representing a family of many number of the angles. So now you have everything you need. So let's play around this now, right? Say if I'm asking you to do sine 1000 degree, what are you gonna do? All right, the first thing first, right? I need to convert the 1000 degree become something within 360. So I'm try. I try to minus 720. Yeah, I can do that. So that become sine 280. Is that right? 720, 280, correct. Because for 720 is a 2 after 360. So if I took away 720, what left is 280. Now 280 is within this diagram. Where are they? Where are they 280? 280 is, let's play around this, right? 280 is somewhere like a, now is a different system, right? The different system compared to the true bearing. Now everybody, the angle measurement starting point is from here. And now the angle is what that called? Counterclockwise. So please, we just learned the true bearing, right? Now it's time to not confuse. Because true bearing, start from here, you're measuring this way. You happy with that? That's a true bearing. But for us to measuring the angle in this unit circle diagram, the starting point is this one. That's a 0 degree. True bearing 0 degrees over there. So the circle is going to looping around like that. So are we clear? What's the difference? So when you're measuring the angle in the unit diagram, the circle, the starting point is here, is the x-axis. While you're measuring the bearing, the starting point is true north, right? And also the direction of the revolution are different. Okay, so with these things in, you should be clear. When we talk about the bearing, you draw a different diagram. When you talk about true sort of not true, when we drawing this circle, yeah, you draw different directions. Now we have the first step down. We have successfully from general angle to something within 360 degree, but we're not done yet, right? So 280, you know where to, because we just said this is 0, right? So this is 90, that's a 180, that's a 270. Now you understand this, each of the direction, it represents different angle. Pure north is 90 degree, pure west is 180 degree, pure south is 270 degree, and a pure east is 0 degree. Now, where's 280? 280 is going to be somewhere 270, but you swing further. So here is further, right? So that's a 10 degree here, but then this is 80 degree there. Okay, now you got that, and you know this is the ray. So are we able to calculate something? So let's see, right? If it's 280, now maybe should I just draw a separate circle so I can make more sense, right? Where should I draw? Maybe I just take this away. I just take this circle away. If I delete that, I'll just draw a new circle. Got that down. So now we can draw a new one. Very good. Good. All right. So we know that 280 is here. Okay. So how to calculate the sine of that? So you are having here, at this point, you call that is nu of xy, but you don't know what to do, right? So here is 80. Now you try to say, is there any kind of symmetry I can draw? I may, right? So if I'm drawing another point like that, you also draw, just try have some common sense, right? Say, how can I calculate a 280 sine? Would it be something the opposite? So it's this part is the opposite, yeah? I'll make a different color, like a blue color, right? So this part is the opposite. R is always positive. But this opposite is always negative. This value should be exactly identical to this value due to whatever you want to call that, isosceles triangle or some other things. So that means you have an idea. It is something with R, but that something, the vertical part is the Y. This Y is negative, right? It's a negative. It's something is like a negative, but it's R, right? This is the R, but this angle is 80. Yeah, it's the same as R times sine 80. So this is the 80 degree, as this one is a negative 80 degree. Can you see that? So that one is actually, that's a negative 80 degree. That one is a positive 80 degree. So you realize eventually this result is same as negative sine 80. Done. That's it. So what we have achieved the transition. Original angle is above 380. You convert to something below 380, 360. Done. But when you try to convert next step, you are going to do quite complicated switch, right? Saying, which part has almost the same value. So which part will give you the same sign value, but potentially different sign. So sign is opposite. This opposite is negative for sure. So that's absolutely negative. You sure? And then this height, the length of that, the same as that, right? So then you realize, oh, it's possible. We can calculate that. Yeah. But you can see this process logically is clear, but the calculation is very messy, right? So does that have to be the case? Do we have any other better way to get a head around of that? There is. There is. So the next stop, how to calculate the next stop, is going to be a lot more complex in the way that we call that quadrant calculation. The quadrant is not yet here. It's in the next stage, right? So next one, we're going to talk about a quadrant. But today, right, we are where we are, right? Well, let me just quickly show you where we are. We are 6D. We are just at 6D. But what we want to achieve is going to be some question. Let me show you, right? 6D, we're going to do some question. Then, and you should expect you're not able to solve all the question yet. But just that you have the ability to draw an array, then you start to do the conversion. Like you draw array, right? The array means you're drawing that, and then you try to convert where they are, particular negatives. Can you draw? So in your head, you should quickly draw. Like I'll just give you an example, right? If I'm saying draw this, negative 440, how do you draw that? So you're not going to make any sense to draw this. You're going to say a plus a multiple of 360. How about a plus 720? That will give me 280, right? It's giving me 280. Agree? That is 280. So once you got 280, you can see 270 is here, 280 is there. So that's called the negative 420. The ray is pretty clear here. Not drawing properly. I should draw a circle that is really, really like a circle. Yep. Then I can touch it. Then I can move. Yeah, that looks like right. So that's the way I'm drawing negative 440. So all you need to learn from now on is how do you make sense? How do you sort of find out where are they? How do you find out where's 440, for example? Where is 550? I already tell you, right? Plus 720, you can get that. Let's move on, see what other questions you have. So for question, this is the different things, right? You're gonna try to lots of rays, and you can try to identify who are they. So then that's the next question, right? Can you please sort of write out sine, cosine, and tangent for each of those questions? So then you just apply the formula. Just I think one thing lots of students in the prior years is confused about is this. They were mistakenly thinking sine theta is x divided by r. Why? Because they think sine is starting, x starting. So that's why it should be x. No, sine is corresponding to y because that's opposite. This part is y. So just remember, sine is calculated by y. That's a very, very important remind is that if you draw that, the opposite is the height. Height is y. So sine is corresponding to y divided by r. So yeah, let's do that as part of homework as well. So probably I'm thinking, right? I'm thinking you need to do 1, 2 for sure. What is the 3, 4, 5? For question 1. Oh, okay. Yeah. So you probably do 1, 1, 2, 3, 4, 5 as well. Not issue. And the 6 is absolutely required. You need to do that. Try to get a head around of this basic concept. When you extend your angle concept above 90, you need some time to get a head around. Diagram shows 0 to 60 at a 60 into circle like that. Okay, use diagram to complete. Yeah, take some time to calculate the 7. I think that the question put in there, there's a reason why. Because that's the way you can get a head around of really who are they, right? So what is the question 8? Question 8 is read through the diagram, correct the 2 decimal place where necessary value of this. So this is the first time you have exposed to sine, cosine diagram. So this is also good. But may not be fully make sense to you at this stage. So also give a try for question 8. Oh, no, I'm not gonna suppose move that. Move back. Cool, move back. Find a 2 value. Okay. Let me just zoom in a little bit. Too many things should delete. The graph of secant. Okay. The graph is probably give a skip. This is just not very important for now. You don't need to worry about. If that one is obtuse find expression, yeah, that one's a good one. Give it a try. Okay, so I think that today's homework is quite interesting. Almost every question except 9. Every question except 9 from 6D, and then from 6C, just do one question. I think we'll just do one question, which is 20. Oh, wait. Yeah, 20 I'm already explained. Maybe just do 19 and 20, both. So that's the homework, guys. Sorry for holding you up for 4 minutes, but that's it for today, guys. Homework 1920 from the last chapter, and the new chapter, all questions. Those questions is pretty fundamental and not very hard. You just read through the notes and see what's going on. And also, the first time ever, you're gonna know what is a 1, 2, 3, 4. Those are called quadrant. We're gonna deal with that quadrant later on. But 1, 2, 3 for the position, how you writing that. This is a like capitalized Latin, right? 1, 2, 3, 4. The domain and the triangle functions. So they start to getting some idea about what value you can take. You literally can take every numbers, right? So yeah, that's it. not much. So after that, I'm gonna distribute from today, right? We're gonna distribute next booklet after today. So you guys just be prepared to print trigonometry number 2. A lot more detail will be explained next chapter. Is just deal with how would you be able to convert a say same question sine 1000. How would you be able to convert to a question that is within the acute angle? Yep, so that's the things we're gonna learn. Next chapter is very complex. Lots of students get it, make no sense of that chapter. So be prepared. All right. Otherwise, see you guys next week. Bye bye.
Thank
Thank you.
Thank you.
Bye.
Thank you.
Okay.